If you understood these slides, these animations, you have understood probably the rest of the video to a great extent. Multiplication of probabilities means bringing together two events such that they form an overlapping zone. The overlapping zone is a zone where both the events are happening simultaneously. It's raining plus you're going out, for example. So multiplication of matrices is bringing together two events such that they overlap. Division of probabilities, on the other hand, means you are taking separately, that is making these events separately. Even if there is an overlapping zone, you are separating these events from each other, tearing apart these events from each other, such that now the overlapping zone either reduces or there is no overlapping zone altogether. If you've understood this much to a great extent, further on you will understand the formulas of conditional probability. In order to understand conditional probability, let's take this example. The blue circle in this image represents the probability that it is going to rain tomorrow. The yellow circle, the probability that you may have to go out tomorrow. Now let's bring these two probabilities together. That will be the multiplication of matrices, and in this an overlapping zone is formed. The overlapping zone indicates the probability that both these events will happen together. That is what multiplication of events means. Both these events will be happening simultaneously. It is this and that. It is raining and you are going out. Now imagine you are asked to find the probability of you having to go out, already given that it is raining. So listen to this carefully. It is already given that it is raining, and now you have to find out the probability of you having to go out. So given that it is raining, you have to remove this probability from the equation. And at the same time, you have to see to it that it is raining and you are going out. While you are going out, it is raining. So we are considering only and only the intersection zone, isn't it? Because we are asked that these two events should be happening simultaneously. Only it is that one of them is already given that it is happening. It is raining, so you don't have to find the probability of it. But given that it is raining, you have to find out the probability of you having to go out that day. So because both of these events are happening, you are dealing only in the intersection zone, which is denoted by the green area. From this green area, from this overlapping zone, you have to remove the probability of rains happening. Why? Because it is already given. So P of R, let's say P of R represents the probability that it is going to rain. You have to remove it from the equation. Now how do you remove something from an equation? There are two ways to do this. One is subtraction. Subtraction is a way of removing. The other one is division. Division is a shortcut to subtraction. So P of R would be coming in the denominator. So from the overlapping zone, that is the green zone, you will have to divide or put P of R in the denominator, the probability that it is going to rain. And that is how conditional probability will be fulfilled. What if there's an ebook where at least the building blocks of math can be visualized with the help of intuitive images like the way you're seeing on the screen? What if sine theta can be visualized as a measure of how perpendicular two forces or influences are. In other words, sine theta comes into math whenever two forces are such that they produce maximum impact when acting perpendicular to each other. What if you can visualize the actual reason of why sine theta equals to opposite side upon hypotenuse with the help of an animated example as you are seeing on a screen? Now, just as sine was a measure of how much perpendicular two forces are, what if you are told that cos is a measure of how much parallel two forces or influences are? Ever wondered why cos 0 is always maximum? The more aligned, the more parallel two forces are, the greater the value of cos theta. Cos, in fact, comes into math when two forces or influences are such that they produce maximum impact when acting parallel to each other. What if complex numbers can be visualized with the help of animations like you are seeing on the screen? I raised to 1, a rotation by 90 degrees. I raised to 2, a rotation by 180 degrees. I raised to 3, a rotation by 270 degrees. And I raised to 4, a full 360 degree rotation. What if someone tells you that complex numbers comes into math when one influence splits into two or more branches either due to rotation or some other reason? One branch is called as the real part, the other as the imaginary part. What if an ebook tells you that complex conjugates are nothing but vertically opposite mirror images of each other? 3 plus 4i is like climbing the uphill of a slope, and 3 minus 4i like going downhill. What if the formula of logarithms can be visualized as the log of every effect gives you the cause of that effect on the other end? The base of log is nothing but the rate at which the cause and effect relationship is changing. What if in integration or calculus, dx and dy means keep adding along the x and the y axis respectively? dr would mean keep adding along increasing radius, dh along increasing height, d theta along a vertically curved path, and d psi means keep adding along a horizontally curved path. What if integration and differentiation can be seen as evil twins of each other, that is, reverse processes of each other? Integration, a process of addition; differentiation, a process of subtraction or taking away. Divergence can be visualized as the rate of change of the field as you move away from the source of the field in a three-dimensional setup. Curl, on the other hand, can be seen as the ability of a field to try to rotate you or spin you in a certain direction. I, j, and k being the three different planes of rotation, three different dimensions in which rotation can take place. What if you are told that the diagonal of a matrix is the axis around which things rotate, and that the transpose of a matrix is the entire matrix or the object that it represents rotated by 180 degree about the diagonal as an axis, and that the transpose of a matrix will be the entire matrix rotated by 360 degrees. Visualizing math 1 is the result of years of hard work done into the research of the meaning behind these equations. What these equations mean are explained with the help of simple and down-to-earth examples, animations, and analogies, so that everyone can understand. Everyone is a beginner at some point. and visualizing math is dedicated to beginners or even advanced users who wish to visualize things in order to understand. It has very little definitions and more of examples and analogies. The link to the ebook is given in the description. It is also available on Amazon as a paperback, the link to which is once again given in the description.